Hi, this is Dr. S Rao, Director, Go Green Technologies. In this session, we will discuss about a IoT kit which is specially designed for training programs, hobby club, and hybrid internship programs. In short, it is all about do it yourself. In this training program, students are supposed to design, fabricate, troubleshoot, develop various applications by using this kit. So we will discuss what do you mean by design in this session. Maybe in the subsequent sessions we will discuss about fabrication and application developments. We named this as a EDU-Robo kit because this also has the ability to make a three-tire vehicle with the help of DC motors and a dummy wheel. On this board, the heart of the board is a CPU which has the ability to control, communicate, acquire the data, process the data, whatever is the application demands, IoT application demands. Several applications can be implemented by using this hardware setup, including some small robotic computations. You can change the CPU. The hardware is designed in such a way that it's not only a ESP-32 microcontroller. You can also change the CPU like Raspberry Pi Pico, Wi-Fi enabled, or some other CPUs. So plug and play mechanism is provided. The base board consists of several drivers, sensors, LEDs, LCD, and on top of it, you can change the CPU. To begin with, we are providing ESP32, which has the board has the provision for 12 volts battery connection, 5 volts DC supply, or 3.3 volts for the microcontroller. And it also has the ability to change the CPU. We have provided interfaced 4 LEDs and one buzzer connected to the microcontroller, and some sensors on board like LDR, temperature sensor, humidity sensor, optical sensor, distance measurement sensor, remote control sensor. So such type of sensors are available on board, and we also provided a optional Burj female 3 pin 4 pin connectors so that the other sensors like gas sensors, accelerometers, such type of sensors also can be interfaced. As a output, the board has a motor driver L293D so that you can connect either two DC motors or one stepper motor. The board is also interfaced with a relay circuit so that any isolated devices can be operated like fans, tubes, air conditioners, refrigerators, even in short, that's all about even AC operated devices can be controlled with the help of the CPU. There is a provision for interfacing DC motors, stepper motors, and servo motors. The board is interfaced with a LCD, text LCD 16 by 2, 16 characters in one line. Such type of lines are 2. However, with the indigenously designed driver circuit, in order to reduce the number of I/O lines using 74HC595 serial to parallel converter. The board is also having infrared sensors interfacing provision for obstacle detection, line follower. We have multiplexed these sensors with the help of analog multiplexer CD4051. Since the applications also demands wireless communication like Bluetooth, Wi-Fi, the board is having inbuilt, the ESP32 is having inbuilt Bluetooth and Wi-Fi for wireless communication purpose for cloud-based applications. Before using the board, before doing the soldering, I suggest you should go through the operational guidelines. One should not be in a hurry for mount all the components. You should mount one at a time, test each and every component, look at the direction of the components. Every component, most of the components have direction. Accordingly, one should mount it. There should not be in a hurry. So in the next session, I will tell you about how to solder the component. Once you mount the components, removing is difficult, so be careful. There should not be any dry solder, short circuits, open circuits on the PCB. Otherwise, you may physically damage the components. So go through the operational manual and see the next video also while soldering the components. In this session, I am discussing about the design point of view. Let us discuss about the design. Eventually, we'll discuss about the interfacing and programming. The board is having multiple sensors, analog sensors, digital sensors. So we have designed this board with the help of a multiplexer, analog multiplexer. So you will find these inputs to the analog multiplexer CD4051 on the board having 8 inputs x0, x1, x2, x3, x4, x5, x6, x7. 8 inputs, 8 analog sensors you can connect, and the output is available on the pin number 3, which we have connected to the AOP-1 connector, which can go to the ESP32 microcontroller or even further matter any other CPU. However, the input is selected with the help of these 3 control signals A, B, C. We have used ESP32 IO4, IO2, IO5. These 3 signals, if these A, B, C are 0, 0, 0, then X0 will be selected. This signal is available at the output pin. If you give 0, 0, 1, second channel will be selected. This sensor input is connected to the ADC of the microcontroller. Similarly, if you give 1, 1, 1, then last channel will be selected. Then X7 input is available to the ADC pin of the microcontroller. So we have multiplexed 8 analog signals, 8 into 1, 8 is to 1, so that by using one ADC channel, we are able to connect 8 sensors. The last channel, we have connected a potentiometer, 10 kilo ohms. If you adjust the resistance of this pot, the voltage will be adjusted somewhere between 3.3 volts to ground. So by varying this pot, you can give an analog signal between 0 to 3.3 volts to the ADC of the microcontroller. So CD4051 is operating on 5 volts. 3 control signals, 8 analog inputs, 1 analog output. So 8:1 multiplexer, analog multiplexer. So if you look at the connector details in the entire manual, you need to understand how ESP32, 15 pins on left side, 15 pin on right side, the connector is provided. If you look at the data sheet of ESP32, you will find pin number 1 is 5 volts, pin number 2 is ground, then the IO signals will start. So 15 pins. Similarly on right side also another 15 pins. So 30 pin ESP32. We will discuss about the pin functions. Like I was telling, we also made a provision instead of mounting ESP32, you can also mount Raspberry Pi Pico W CPU so that you can, instead of ESP32, you can choose another company CPU for interfacing and programming purposes. So we made a compatibility, a choice that which CPU you want to mount. So while soldering itself, you can make a choice. The board consists of LCD interface. LCD is a text LCD. 16 characters you can display. 2 lines are there, so it is called 16 by 2. LCD is having 16 pins. To begin with, first is ground, second is 5 volts, third is contrast adjustment. We are connected to ground with the help of 2.2 kilo ohms resistor. The fourth signal is register select, which will select the internal registers of the LCD. This will decide whether you want to send data or command. Data means ASCII values, which you would like to display it on LCD. Command means like clear display, first line, second line, position the cursor, blink the cursor, size of the character. Those are all the commands you can give it to the LCD. So that selection is done with the help of the RS signal. Read oblique write bar, we made it permanently ground so that it is always in the write mode. So CPU will write the data to LCD. We are not reading anything from LCD. Then enable. Enable means whenever you give any data or command, you are supposed to generate a enable active high signal on this pin, 6th pin. 7th pin to 14th pin is actually data bus, 8-bit data bus. Instead of 8-bit, we have preferred 4-bit so that the 4 lines you can neglect. DB4 to DB7 we are using. So nibble by nibble, 4-bit at a time, we are sending the data. Then 15th pin is again VCC, 16th pin is ground. This VCC ground is for the yellow LED, backlit LED. Instead of directly connecting the LCD to the microcontroller, we have used this serial to parallel converter 74HC595 in order to reduce the number of IO lines. Actually, you require 4 plus 3 IO lines. Instead of that, we have used D1, D2, D3, only 3 lines. With the help of 3 lines, we are able to interface the microcontroller to the LCD. So how this is done? The serial to parallel converter 74HC595, the data you can see the clock and the data, D1, D2, D3, which are coming from the microcontroller, is converting the serial data to parallel form DB4, DB5, DB6, DB7 and register select, right? QC, QD, QE, QF, QG. These signals are connected to the LCD. So maybe the software is slightly complicated, but however, the hardware is simplified because microcontroller requires only three data lines D1, D2, D3. So this is indirect way of reducing the IO lines and interfacing serially controlling the LCD, text LCD. The board has enough number of connectors, Burge female connectors, 3-pin, 4-pin connectors so that you can connect the sensors. Please note the pin functions. Looking at the pin functions only, you connect the sensor so that if you reverse the direction of the sensor, you may permanently damage either the microcontroller or the sensor. Say for example, if you are using the sensor connector, let's say IR-F, first pin is 5 volts, second is ground, third pin goes to X0 pin of your multiplexer. That is this first pin. So if you want to select this sensor, then A, B, C should be 0, 0, 0. That is IO4, IO2, IO5 should be 0, 0, 0. So if you give 0, 0, 0, then this signal is connected to the ADC pin of the microcontroller. Fourth pin is not connected. So that means whichever is the sensor you are connecting, make sure the sensor's first pin is 5 volts, second pin is ground, third pin is either analog or digital output. So such type of sensors 1, 2, 3, 4, 5, 6, 7. Total 7 connectors are there named as IRF, IRB, IRML, IRMR, IRLF1, IRLF2, IRLF3 on the PCB. All of them have same connections like first is VCC, second is ground, third is signal. So you can use any sensor, but we have provided these sensors particularly for either line follower or the obstacle detection. However, you can also connect other gas sensors or some any other like humidity, distance, such type of sensors. Make sure they are pin to pin compatible. Similarly, looking at the market, the type of sensors which are available, we also made a provision for interfacing pressure sensor, accelerometer, sound sensor, servo motor, touch sensor, DHT11 sensor, vibration sensor, ultrasonic sensor, and sharp sensor. Because these sensors, the pins are not same. They have a different pin configuration. So be careful while mounting these sensors again. Cross verify. Pin number 1 is supply, pin number 2 is ground, 3 is signal, 4 is signal in case of a pressure sensor. In case of an accelerometer, first is ground, second, third, fourth is signal, fifth is supply. In case of a sound sensor, first is VCC, second is ground, third is your signal X1. X1 now see, look at X1. X1, this X1 is same. That means either you can mount this sensor or you can mount this sensor because we are use the same pins. Similarly, X4, X3, X2, either you mount ADXL or you can see X3, X4, right, X2. So either mount these sensors because we use the same signal. Servo motor. Servo is not a sensor. Servo is output which works on a digital signal, PWM signal. You don't need any driver circuit, just you require a pulse width modulated signal. Some other video explained about the DC motors in EDU-Robo DC motors, servo motors, stepper motors video. How it works. However, interfacing is done with the help of this signal, servo signal. What do you mean by servo signal? You should look at the microcontroller where servo, that means you can see this signal, this IO pin is connected to the pin number 9 is connected to the servo motor. That means when you write a program, make sure this pin, IO pin, you program it for generation of the PWM signal. Then about the touch sensor. First is ground, second is VCC, third is IO18. So IO18 means you should look at IO18, you see this signal. This signal is connected to touch sensor. So if you want to write a program to read the touch sensor, read the IO18 pin. Similarly, DHT11. DHT11 is for temperature and humidity. So pin number 1 is VCC, second is signal, third is ground, which is connected to IO19th pin. IO19th here. So write a program to read the IO19th pin so that you can read temperature and humidity. Similarly, the vibration sensor. First is VCC, second is ground, third is IO23. So look at the vibration sensor. IO23 is this pin, last pin, that is the right side last pin, that is as good as 30th pin. So this sensor, you should read it if you want to read the vibration signal. Ultrasonic sensor, first is 5 volts, second is signal, third is signal, fourth is ground. So DAC input 1, DAC input 2. These are nothing but you can see these are the IO pins. 8th and 7th pins are used for interfacing this ultrasonic sensor. Sharp sensor is first is signal, second is ground, third is 3.3 volts. Sharp is meant for measuring the distance. However, X5 is also already used here, X5. So either you mount this sensor or mount this sensor. So what you should notice from the design is that some of the signals we have shared at multiple places. So while mounting, since they are available in the budge strip, female connector, mount any one of the sensor, either this or this, like that. Otherwise, you are going to overload both the sensors. It may lead to malfunction because it will overload. It is called bus contention. Only one sensor should be there at a time if they are sharing the signal. Okay, so this is for sensors interfacing slots. The board is having a on off switch because externally you can connect a battery. So if you connect a battery on this battery connector, you have a 9 volts or 12 volts battery. If you connect it, then the board has a regulator which will convert this 12 volts or 9 volts into 5 volts. So the 7805 regulator IC will convert 12 volts to 5 volts. So the entire your board will get 5 volts, but this 12 volts is given to the motor circuit. Only motor is using 12 volts. So it is your choice how do you want to operate your board, right? Either the battery, external battery, or by using USB of the microcontroller. So this on off switch is meant for either battery operated external power supply or USB based microcontroller. When you are programming the board, make sure the switch is off, because if you make it on, then what will happen? The entire board is connected to the external source. It may overload your microcontroller. So first initially switched off this, program the microcontroller, then switched on so that no overloading takes place. And also if battery is there, then you have to close the switch. If battery is not there, open the switch. If you want to interface DC motors, stepper motors, the amount of current the motors draw is more than 500 milliamperes of current, maybe even more than that. And even the voltage is above 5 volts, 9 volts, 12 volts motors. Since it is not possible to the microcontroller to drive to source that much current, apply that much voltage, generally external driver ICs are used. L293 is a half bridge circuit where you can have, it has two half bridge. One is, you can see this 1A, 1Y, 2A, 2Y. This is one half bridge. Second is 3A, 3Y, 4A, 4Y is a second half bridge. That means you can connect two DC motors across Q0, Q1, you can connect one motor. Q2, Q3, you can connect another motor. So they are available on this 5-pin connector Q0, Q1, Q2, Q3. That is Q0, Q1, Q2, Q3. And the first pin is common, which is 12 volts. This 12 volts is coming with the help of your this external battery connector. The inputs to this motor driver IC is M1, M2, M3, M4. So you require 4 signals to drive two DC motors. Say for example, if M1 is 0, then Q1 will be 0. If M1 is 1, Q0 will be 1. Similarly, Q1 is related to M2. So that means if M2 is 0, Q1 is 0, M2 is 1, Q1 is 1, like that. So input, output, input, output, input, output, input, output. And there is a one common enable signal on pin number 9 and pin number 1. So this is connected to IO22. So if you look at the microcontroller interface, M1, M2, M3, M4. So these are, you should look for M1, M2, M3. These, that is 6, 5, 4, 3. They are connected to DC motor driver circuit. Also IO22. This is for to enable the IC. That is, let's say if you want to control the speed of the motor, then the enable signal, that is through IO22, you can generate a PWM signal so that the motor speed can be controlled, and the direction of the motor can be controlled based on M1, M2, M3, M4. Let's say if M1, M2 is 0, 0, first motor will be off. If it is 0, 1, it will rotate in one direction. If it is 1, 0, it will rotate in opposite direction. If it is 1, 1, again it will be stopped. So in a DC motor, if one signal is active, other signal is 0, then current will start flowing. If you reverse it, the current will flow in opposite direction. If you give both the signals either 0, 0 or 1, 1, no potential difference, no current will flow. Similarly, the case for M3, M4. So by using this DC motor driver circuit, you can connect either two DC motors or one stepper motor, because stepper motor requires 4 windings. Again, you can refer EDU-Robo DC servo stepper motor video, which is discussed in session 8. So the number of IO signals required to drive this motor is 5 signals. Enable is connected to IO22. M1 is connected to IO27, IO14, IO12 and IO13. So you should write a program and make them high or low, or both low, both high, or forward 0, 1, reverse 1, 0. And speed control, you can do it with the help of enable signal by generating a PWM signal. So this motor you can also drive with the help of this internal 5 volts. If you close this jumper JP1, then you don't need external 12 volt supply, because you have short circuited 5 volts to 12 volts. So you should be careful, because if this jumper is closed, say for example this 5 volts jumper is closed, and if you connect a external battery, then you are damaging the microcontroller, because this 5 volts jumper is connected to the 12 volts DC battery, then that means the 12 volts not only applied to the motor, but it is also applied to the entire your microcontroller. So be careful. Either you operate on purely 5 volts DC supply, entire board, or if you are using external battery, then make sure this is removed. This jumper should not be there. Otherwise, you will damage. First of all, undoubtedly, microcontroller will be damaged, not the driver IC. On ESP32, by default, inbuilt LED is interfaced. However, on the board, on the PCB, we have interfaced 4 LEDs. They are connected, all cathodes are connected together and grounded. Anodes are connected to M1, M2, M3, M4, where the motor is also connected. However, there won't be any conflict, no contention, because they are LEDs. They only indicate the status. They won't give you input, they are outputs. And they won't overload also because you have a series resistor. So IO27, IO14, IO12, IO13 are connected to the 4 LEDs. You can write a program to make them on and off, or you can use operators to rotate left, to rotate right, or you can generate PWM signal to flash the LEDs, or you adjust the PWM and frequency in such a way that you can control the intensity of the LED also. Means you can control the average current flowing through the LED. You can create a array, output the data. You can create a pointers, output the data. You can read the switches, read the sensors, output the data on LEDs. So there are several ways you can test the LEDs. At least 10-15 programs you can easily write on these 4 LEDs itself. Buzzer is another output which is connected to IO15 of the microcontroller. So again, you can write a program to make it on, or you can also generate PWM signal to generate various tones, various musical tones on IO15. It's a digital buzzer. The next is about the sensors. Sensors are the inputs. One input is connected TSOP1838, which is a infrared sensor based on the TV remote, or for that matter any remote, any infrared remote. If you press the switch on the remote, it will generate a bunch of pulses as a it is a coded every key as a coded pulses. Those pulses will be received by the sensor. Then you can read this pin, out pin. It's already, the provision is there on the PCB for soldering. First is, this is 5 volt, second is ground, third is the output. This output is we have connected to the microcontroller TXT pin, where you can read this pin to read the data to verify which switch is pressed. Good number of applications you can implement by using the remote control, like robotic operations, switching on, switching off the LEDs, or selecting various operations by using case statements and so on. LDR is a light dependent resistor. However, this light is not infrared. TSOP is infrared sensitive, but LDR is a ambient light. The spectrum is a ambient spectrum. So one side of the LDR is connected to 3.3 volts. Other side is connected to ground through some resistor, and this potential drop across the common point is connected to microcontroller AOP6. So if the light falls on this LDR, light dependent resistor, the resistance will decrease because of the photons. It will start conducting, and this potential 3.3 volts will appear here. As the light increases, the potential will increase. As the light decreases, then resistance will increase, drop will decrease. So you can read the voltage across this point with the help of the microcontroller. Again, you can display it on LEDs, LCD, or you can also use Wi-Fi, Bluetooth for communicating to display it on mobile phone or a cloud platforms. Or you can control the relay for daytime, light time, uh, to switch on, switch off the bulb, fan, like that. The next sensor is a Hall sensor, Hall effect sensor. Hall effect sensor is sensitive to the magnetic field. So if you bring any magnet, permanent magnet close to the Hall sensor, then the output pin voltage state will change based on sensitive to the north pole or south pole. So Hall effect sensor means based on the magnetic field, the current is induced inside the sensor, and that potential drop voltage is generated on the pin number 3. So it is pulled up to the VCC with the help of 10 kilo ohms resistor. LM35 is a temperature sensor. It's a semiconductor device. It looks like a transistor. It's a 3-pin transistor. One pin is connected to 3.3 volts. You can connect even higher voltage, but we have connected to 3.3 volts. Third pin is connected to ground. Second pin is output. So we have connected to AOP pin of the microcontroller, which is an analog output. Based on the temperature, every degree centigrade will give you corresponding millivolts output. So you can read the pin to know what is the temperature. So the temperature could be anywhere from 0 to 100 degrees centigrade. You can apply. The next sensor is an optocoupler. Optocoupler is a optical. Optical means one side there is a transistor like a LED, other side there is a detector. So light emitting diode, it's already connected, right? This LED is already connected to 3.3 volts and ground. It is emitting the light, infrared light, but it is fabricated inside the IC. So light is not visible to you. Other side, the photo detector is there, another diode. This is also already biased. You can see it's connected to one side, it's connected to ground, other side is connected to pull up. So if the light falls, then the output will be at a low state. If the light doesn't fall, right, if you put any obstacle in between, light won't fall, then output will be high state. So you can read on AOP 5 pin of the microcontroller so that you can put a obstacle in the slot. You will come to know light is there, light is not there. It's majorly meant for detection of an obstacle like credit card readers or like a door closing. So or like in printers, robots, where if any obstacle is there between the slot, immediately the state will change. We have provided in this design a relay, a electromagnetic relay. This relay is isolated, isolated in the sense in the, you can see normally open, normally closed, common point. On these 3 pins, you can connect even 230 volts AC or high voltage DC circuits like fan, tube, bulb, TV, even some extent refrigerators, air conditioners, any high voltage signals, right, up to some 5 to 10 amperes of current, 230 volts, it can withstand. But this is completely isolated because it is connected magnetically coupled. Means there is a inductor coil inside a relay, as you have seen in case of a like a calling bell. Whenever you press some button, the hammer will start hitting the bell. So same thing is here. It's a magnet. There is a coil. If a current passes through this coil, magnetic field will be generated. This normally closed point will be moved towards the normally open. And if you switch off this transistor, current will stop flowing through this coil. Then this normally closed, right, again will reach to the same state because you have switched off. So it will move from the open to closed. So it is your choice. Initially you want to switch on the AC, switch on the fan, or switch off the AC, switch off the fan or bulb, whatever. Accordingly you can choose where to connect the circuit, either on normally closed or normally open. Okay, but relay you cannot directly connect to the microcontroller like LED or buzzer, because like DC motor, relay also draws substantial current. At least minimum 100 milliamperes of current it will draw. If you use the bigger relays, even it may draw half a ampere current. Like solenoid valves, it may draw even amperes of current. So you cannot directly use the microcontroller to drive the solenoid valves and relays, DC motors. First of all, they are inductors. Inductor current, it's very difficult to handle by the microcontroller because it's not a DC current, it's a transient current. Second is the amount of current they draw is huge. Maybe sometimes steady state is different, and once it is operational, the current is different. So that's called transient current. So microcontroller cannot handle that. So again, we use a external driver circuit. You can see here. What we have done is there is a optocoupler, like we have discussed here, optocoupler, same thing here, same concept. One side you have a light emitting diode, other side you have phototransistor. Whenever this LED through microcontroller, if you make it on, then light will fall, the transistor will start conducting. If you make this LED off, transistor will be off. So that means between the LED and the transistor, there is no electrical connection. That means no current is flowing. The connection is optical connection, optically isolated, like your TV remote. You are operating your TV without touching because it's communicating optically. Like your air conditioner, you are operating with the help of a remote optically. So similarly here, this entire relay circuit, you are not directly connected. You are operating optically, right? So the secondary side, this phototransistor, one side collector is connected to VCC. We have connected again the same battery because a relay also requires at least somewhere around 9 to 12 volts. You can also get 5 volts relay. So the other end emitter is connected to this transistor. This transistor is driving the relay, and this transistor is driven by this optocoupler. And one LED is connected in series to the transistor, so that whenever this relay is on, this LED is also, when it is forward biased, this LED is also forward biased, and LED indicates that relay is on. So that is how you can switch on or switch off this relay optically. And this 230 volt circuit is switch on or switch off magnetically. So two isolations are here. One is optical communication, second is magnetic communication. That's how we have isolated one circuit here, we have isolated, other circuit we have isolated here because of the optical. When the relay will be on, if this cathode, because anode is permanently connected to VCC, so if this cathode is given 0 volts through microcontroller, right, you can see RX0 pin of the microcontroller is connected here. So if this cathode is given 0, this transistor will be forward biased. Then this optocoupler will be on. So current will start flowing. It will drive the transistor. Transistor will be forward biased. The relay will be energized, and this relay will be on, which is normally close to, it will close the normally open point. If you give high voltage here, high state, let's say high means 3.3 volts. Since anode is also 3.3 volts, cathode is also 3.3 volts, this LED will be off, this transistor is off, no current will flow to the base of the transistor. This transistor will be in the off state. So no current is flowing through the relays coil. So this coil will be in off state. The relay won't be on. That means the relay is normally closed state. So that's how you can operate the relay like a LED on off on the RX0 pin. Just remember the relay is connected to 12 volts battery, external battery. So the same point here. If you close the jumper here, this jumper means now it is as good as the relay is also getting the same voltage. So you should be careful. Either you are using internal supply of 5 volts or you are using the external supply of 12 volts. If you are using external supply of 12 volts through battery, then do not put this jumper here. So that microcontroller is operating by USB power supply, and this motor as well as this relay is operated with the help of the external battery or DC supply. Alright, so that's about the design part. So far we have discussed the features, how many output devices are there, how many input devices are there, how many sensors are there, how many motors we have interfaced, LCD we have interfaced. And this board is designed in such a way that you cannot copy paste the regularly available online programs. That will at least avoid copying the software. If you buy the Arduino boards, Raspberry Pi boards, then there is no design, right? It's a ready-made boards from these Chinese companies, low-cost boards, but indirectly you are encouraged to copy the codes because the whole world is using the same board, same programs. So you will never ever get any patent or any publication because there is no design here. However, this entire board, the selection of the components, selection of the sensor, selection of the controller, selection of the sensors, everything is our choice. We also seen the LCD is not directly connected. Sensors are not directly connected because we have used a multiplexer and so on. So it is our design. So naturally you can patent it, you can make a product because it is indigenous. And you can in education also you can start copying the things because the codes as it is, copied codes as it is doesn't work because this design is not in the public domain where the whole world is using. Though it is a slightly costly because we are not a mass manufacturing like Chinese companies, but it will avoid this copying and save some money because design fabrication you are doing, there is a lot of learning is happening, and as and when you want to design your own board, we will help you to provide the source files or will teach you the how to design using CAD tools, how to make the PCB so that you can also make your own product. Now let us discuss about how the components are placed. Let us discuss about the placements of the components. Even while soldering also, first of all, you should understand which component is where. First, locate the components based on, so far I have discussed about the circuit diagram. So if you look at the PCB, this is the placement of the components. Let's say for example, you see where is the node the ESP32. You can see this burge strip outside this and this 1 to 15 and 16 to here you can see 30. this and this outside. These two are meant for ESP32. And inside, if at all, if you want to mount the Raspberry Pi Pico W, then there is a provision, this and this. So any one of them you can mount, not both. Or alternatively, you can choose any one of them. So birch female, you are supposed to solder it. That we will discuss in the next session. And so this is the CPU. Where are the resistors, capacitors? You can see SMD. These are all SMD. This square box you can see rectangular R9, R11, R12, right? R13, R1, R10, right? R7, R8. You can see R2, R3, R4, R5. So you should look for the components, right? You can see R8, R9, R11, R12. So you should look for first where the SMD resistors are there. So first one should solder only resistors first, SMD components, because they are tiny. They doesn't have holes. They are mounted on the surface, means top side of the PCB. Wherever these pads are there, green pads are there, they have holes. That means you can solder them from the bottom side of the PCB. So first solder the resistors and capacitors C3, C2, C1. They are meant for biasing capacitors, decoupling capacitor, so that in case of any ripple is there on your supply, they will bypass the ripple and keep the DC constant. So three bias capacitors are there, and once these SMD resistors capacitors are soldered, then you should look where the LEDs are there, on board LEDs. These are also SMD, LED1, LED2, LED3, LED4. However, they have the direction. You can see this side it is negative, this side it is positive. Towards the resistor it is negative. If you look at the circuit diagram, you can see towards the resistor, cathode is there, negative is there. So similarly, while soldering the LED also, towards the resistor, this point where some green line will be there on your LED, the green line should come towards the resistor. So first solder resistor, solder LED, solder capacitors. That's all. First one should do the SMD part. Then you have two SMD integrated circuits, ICs. CD4051 16-pin SOIC and CD595 74595, which is serial to parallel converter, again 16-pin SOIC. Since these are also soldered on the top side of the PCB, I recommend first you should solder this IC and this IC. That's all. I suggest one should start with the SMD. However, before doing all these things, there is a possibility that there may be some defects on the PCB. Manufacturer may have some defects, though our circuit may be correct, our layout may be correct, our placement of the components may be correct. But because of the chemical process while making the PCB, because the copper it will etch it, right? Then drilling takes place, silk screen, green masking, a lot of chemical processes are involved. There may be a possibility of short circuit, cuts, and so on. So just physically verify, is there any short circuits, open circuits on your PCB? Means manufacturer defects. Second thing you should immediately test is there any short circuit on the PCB? Means between the VCC and ground, there should not be any short circuit. If any other signals are shorted, that we can rectify later on also. But if VCC ground is shorted, then the components will be damaged. So before you mount even a single component, make sure there is no short circuit on your PCB. between VCC and ground. So where is your VCC and ground? You can see 5 volts and ground. So between 5 volts and ground, there should not be any short circuit. So take the multimeter, keep it in a continuity or in resistance mode. Make sure there is no resistance. The beep sound will come if there is no resistance. Or on your LCD connector, you see pin number 1 is ground, 2 is 5 volts. So keep the multimeter negative, that's a black terminal on the first pin, red probe on the second pin, which is 5 volts. Check is any short circuit is there. So on your PCB, right, where is the LCD? You can see this is the LCD 16 pin connector. So pin number 1 is ground, 2 is 5 volts. So keep the multimeter probe on black on first pin, red probe on second pin. Check the continuity. If there is no short circuit, then only you should start mounting the components. That is the at least minimum test you should do it. If there is a short circuit, do not mount the components unless you find out the short, remove the short. Okay, that's the minimum test. That is called continuity test. After that, only mount SMD components, resistors, capacitors, SMD resistors, SMD capacitors, LEDs. Okay, I will tell you afterwards also. Okay, so this is about the resistors and capacitors and ICs CD4051, which is a analog multiplexer, and 74595, which is serial to parallel converter. So these are the two ICs which we have located. After that, where are your power related components? One is, you can see your on off switch. You can see that on off switch, the blue colored switch, we are supposed to mount it on this left side 3 pins, right side 3 pins. Again, there is a direction is here because it is a push to on. If you press it, it will be on. If you release it, it will be off. Even if you reverse it, nothing will happen. Only difference is if you release it, then in that case it will be on. If you press it, it may be off. So what you should do is, while mounting this switch, below the switch there is a hole. That hole should come this side. This side means towards this battery connector. The hole should come this side. You can see there is a white mark here. White mark this side. Opposite to white mark is this. So your hole should come this side, opposite to this white mark. That's the one way of remembering that, push to on. And since if there is a mismatch on these holes, slightly bend those pins of the switch so that it will properly insert into these 6 pins. So because power on off switch. Then your regulator 7805, 3 pin, look like a transistor. Exactly, look at the flat side of the transistor, put it into this slot transistor. So these are the two components which are related to giving the power to the board. Then you have the other components, like you can see the diode here, D1 1N4004. It has a direction, silver band is this side. Bend the diode in a right angle, insert it here. There is a LED here, 5 mm LED, again positive this side, negative outside, flat side of the LED should come outside. Long lead, or you can say long lead of your LED is inside the PCB, short lead is outside the PCB, right, towards the diode. So put the LED here, sorry, light emitting diode, mount the diode, light emitting diode, and the normal diode, power diode. Power diode has a silver band. So LED and diode mount it here. And then you have another IC called optocoupler PC817. Again, it has a direction. Wherever name is printed, that side the dot portion of the IC should be inserted. That indicates pin number 1. So this side it should come. Then transistor, BC547 transistor, which will drive this relay. So mount BC547. Again, flat portion should come this side. So that's the direction. Okay, so that completes the your driver for the relay components. Then let us mount one by one the sensors. One sensor is your temperature sensor LM35. If you have mounted, again look at the flat portion of it. Hall effect sensor, again it has a direction, look at the flat portion, accordingly you insert it. If you have a that TSOP sensor, TV remote sensor, again look at the direction. The window portion, flat portion should be to back side of the PCB and front side is outside the PCB. That window portion, TSOP sensor, that should be here. Mount this sensor. Then there is another sensor here, light dependent resistor LDR. Mount this sensor. This doesn't have any polarity. In any direction you can insert it. So mount LDR, mount this TSOP sensor, mount this temperature sensor LM35. And now about the optocoupler, optically isolation, right? Optical sensor for obstacle detection. This again has a direction. On the optocoupler, the name is printed, optocoupler name. That name should be outside the PCB. The name should face outside the PCB, this side. So insert exactly these 4 pins, which should face towards the outside the PCB. These 4 pins it should match. But before putting the optocoupler, like I said, make sure SMD resistors are soldered so that it will be difficult after that soldering the SMD components. So this completes your sensors mounting. Now now the remaining is about only the connectors, the burge strips. Burge strips are, you can see, first of all ESP32. One is here, another is here. Break 15 pins. You are given 40 pin burge strip, break it into 15 pins. Exactly the 16th pin you cut it and insert the burge strip here and solder one strip here, another strip here, which is a female. And all the sensors, right, infrared sensors, all these sensors, female connectors, use burge strip. I will show you again while soldering, but just remember these are all burge strips, except the LCD connector is not the female burge strip, it is a male burge strip. Even the motor connector is also male burge strip. So one is here, another is here, LCD connector. Similarly, the jumper, which will be shorted if you do not want to use the external battery. So that jumper is here. You have to close it. You close it if you do not want to use the external battery. Means by using this microcontroller USB power supply, if you want to drive this motor, then close this jumper. Otherwise, do not put jumper here. You may damage the microcontroller, because if you short this jumper, this battery supply is also given to microcontroller, which will damage it. That mistake we should not do it. Okay, then buzzer is also have a direction. You can see the positive long lead should come this side, short lead will be this side. So insert the buzzer. So this completes the components which we have thought of providing, and the sockets where additional sensors externally you can put it here. And then finally the bigger components, bigger size components is a relay. The relay, which is a electromagnetic relay, bigger in size, you can solder it here. Similarly, the 3-pin connector, one here, 2-pin power connectors, one for battery connection, other is for external uh, that fan, tube, bulb. If you want to operate with the help of the relay, that you can connect it here. So this relay, X3 connector, battery connector, you can mount it, solder it at the last stage. And one IC socket is here, 16-pin IC socket for inserting the motor driver. You can solder even this one also while soldering this barge strip for the microcontroller ESP-32. Both you can do it in the initial stage itself. So I will show you one by one while doing the soldering in the next session. But in this session, try to understand which component is where, so that when you want to test the sensors or you want to put the sensors, for example, DHT11 here, vibration sensor here, servo motor here, pressure sensor here, your potentiometer, 10 kilo ohms potentiometer here, accelerometer here, and then temperature sensor here, LM35, Hall effect sensor here, sound sensor here, external motor, DCR stepper motor here, and all object detection, obstacle detection, infrared sensor, IRLF1, IRLF2, these are all you can insert here. Sharp sensor you can insert here. So the board is touch sensor here, and infrared sensor one here, another here, one here. So the board has enough provision for interfacing several sensors, so that in case of a IoT application, Internet of Things, you can implement different types of case studies, good number of case studies. That's the beauty of this board, which we have not only made it for the as a hobby club for learning practice of programming, but good number of case studies also you can implement by using this board. All right, so that's about the placement of the components and identification of the components, which component is there, so that while soldering and troubleshooting, programming, testing, you should know first which component is where. When you design your PCB, is also important to understand how to place the components. While designing the circuit, you can choose the components, it is your choice. But the footprint means on the PCB actually how the component looks like. What are the dimensions in the market, which components are available. It's very, very important. Otherwise, you make the PCB later on when you buy the components, then there is a mismatch. Then, your soldering will be difficult, or sometimes it's not possible also. Okay, so exactly the same whatever you have seen in this slide is converted into printed circuit board. You can see this is a FRC4 sheet, right? Non-conductive sheet. On the non-conductive sheet of FR4, you have this copper tracks are there. They are etched in such a way that the way you have designed the circuit exactly implemented on the PCB. So again, you locate, right now I explained these four LEDs. So they are here, your R2, R3, R4, R5 resistors are here, right? Then other SMD components, R8 here, R9 here, R11 here. First you should locate where are the components, R13, R1, right? And then your, let's say for example, temperature sensor, buzzer here, your TSOP, infrared TV remote sensor here, battery connection here, on off switch here, regulator 7805 here. So you should locate first where, which component is where. Your ICs, SMD IC CD4051 here, 74595 serial to parallel convert here, potentiometer 10K here, like that. So location of the components is very important, so that in the next session I will teach you how to solder these components. Or when you design your PCB, maybe in the internship program, I will tell you how to design your own PCB. Because patent product you can obtain only if you design your own circuit, you design your own PCB. Software development is okay, nobody is going to see you, but PCB everybody will see you how it looks like. So you cannot take Raspberry Pi boards, Arduino boards and make a product, then right, it's not a product, it's already there in the market. You just copied the things, nobody will give you publication or patent, or nobody will buy your product because already there. So anybody can copy your product, but this is your design. as long as when you don't disclose, nobody knows which component is connected where, how it is decoded, encoded, designed. That is a confidentiality part of it. That's the business. Once you solder the component, like I told you, your ESP32 Burge strip. I didn't solder this Raspberry Pi socket, as I told you, any one of them. Right now, we have soldered only for ESP32. Female Burge here, and then your motor driver IC socket, DIP 16 pin, and all these female Burge sockets, they are for sensors. But before mounting these things, I told you, solder only SMD resistors, right? SMD capacitors and LEDs and SMD ICs. First, you should solder these things. After soldering these things, then solder your LEDs, and then send like transistor 7805, BC547, LM35 temperature sensor, and LDR, LED, diode, optocoupler, PC51. You can see there is a dot here. This is pin number 1, should face toward the outside of the PCB. Optocoupler, again you can see the plus is written here or E is written here, or actually on the front side some name is printed. That should face towards the outside the PCB. Even this ICs, there is a one dot here. So wherever name is printed, that dot should come here. Similarly, here dot is there, name should be there. So direction is very important. So you should solder first all SMD components, then these discrete components like transistors, diodes, LEDs. After that, now you can solder these Burge strips. Again, there is a difference. This is male LCD connector, motor driver, 2-pin jumper. These are male. Again, you have a servo motor connector. This is a male 3-pin. These are only male. Rest of them all female, right? This ESP32 socket is female. Sensors are female connectors. One pins are there for buzzer and this LDR. That single pin Burge strip, you can break it and insert it here. Two more are available here that you can use it. And finally, relay, this blue colored one, insert there is a direction. Even these power rail connectors, there is a direction. Direction in the sense the wires should be inserted from outside. So that should be visible. The screws where you insert the wires, they should be towards outside. You can see here also the battery connection. This side positive, this side negative battery connection. There is a direction. If you reverse it, this PC will be damaged. And this on off switch, again I told you, there is a direction. So while inserting below the on off switch, one hole is there. That hole should come this side towards the battery connector. Even this, your TSOP TV remote sensor, you can see the window portion that should face towards the outside. Even the buzzer, you can see the positive plus is written. This should be inside. LED again has a direction. Positive is inside, negative is outside. Long term, long lead should come inside, short lead should go outside. Pot 10K, there is no direction. LDR, there is no direction. However, diode has a direction. So silver band, you should match it. So be careful. This even the transistor, flat portion this side, flat portion this side, flat portion this side. You should match it. Alright, so you should look, that's the placement of the components. While soldering also, again I will explain how to solder one by one. After populating all the components and insert finally your, yeah, I was telling you about the short circuit testing. When you see the LCD connector, the square portion, this is pin number 1. Between this pin, which is ground, second pin 5 volts, there should not be any short circuit. If short circuit is not there, then only you should start mounting the components. Once all the components are populated, then insert the ESP32. Again, do not put in a reverse direction. ESP32 will be damaged. The direction of the ESP32 is this USB connector should be towards this on off switch. Even when you put the USB cable, it has a direction like your mobile charger. Same way, the direction, the flat portion is on the top side, and uh, it has a D shape, right? The longer side is on top side, shorter side is in the bottom side, and this should be facing towards the on off switch. So direction is very important. Second is all these 15 pins, right, on left side and right side should match while inserting this ESP32. Even if there is a mismatch on these 15 pins, either left or right, then instead of VCC, ground may be connected. Instead of ground, VCC may be connected. It may damage. First ESP, this board will be damaged. Once electronic component is damaged, then it is irrecoverable. Software won't damage, but hardware, yes, it's a semiconductor. Once the junction is heated up, then it will be damaged. So be careful. You should have a lot of patience while mounting the components. So these are all the list of the components which I already explained. Go through this sheet one by one. You should pick up SMD components first, then SMD capacitors, then discrete components, then SMD ICs, then sensors, then finally the female birch, male birch, then the your relay and the power rail connectors. Once everything is tested, just give the power, see LED is glowing, no short circuit, then only insert the ESP32. No hurry in putting the ESP32 in the first step itself. There are some external sensors like DHT11 accelerometer, right, or ultrasonic sensor, servo motor. So when we give it, like I was telling about the connectors, carefully you should look at. For example, if you see this DHT11, pin number 1 is VCC, second is the signal, third is ground. So when you want to put this sensor on your PCB, you should look where is that DHT11 connector, right? So if you see DHT11 is here, but then in this, in which direction you will put? This side you will put or back side you will put. So be careful here because see pin number this one first is this fellow is ground, right? So ground means now you should look at where is ground. So your ground is here. So this pin should come exactly right here. Your first pin I have written plus, first pin should come here. Second is signal, third is ground. So third should come here. That's the direction. If you reverse it, sensor will be damaged or the controller because the entire power supply is coming through USB of the controller. Controller will be damaged. Once damaged, it's irrecoverable. So every sensor has a direction. Let's say accelerometer. Say first pin is VCC, three signals, ground. So where is accelerometer on your on these slots? If you maybe it's not readable, but on the blank you can see where is the accelerometer. Okay. So if you look at the accelerometer here, this is the accelerometer. So when you put the accelerometer here, again you see the plus symbol is given here. So wherever the plus symbol is given, that is the indication of the pin number 1. Okay, wherever possible I had given some indication. So you should see our simplest way is take the multimeter VCC, that is the best practice. If you want to put the VCC to VCC, check on this 4 pin connector, right, which is VCC. On your LCD which is VCC, your second pin is VCC, first is ground. So this second pin you try to check which pin VCC is coming here. So exactly while putting this also, the first pin VCC should match. That's the beauty of easiest way to insert those connectors. Similarly, ultrasonic sensor. First pin is VCC, then two signals ground. So where is the ultrasonic connector here? This is where the ultrasonic here. Again, If you look at the direction here, plus symbol is given here. That is the pin number 1. So while putting the ultrasonic sensor, make sure the VCC goes to VCC. That's the care you should take for every sensor. Some sensors I didn't mention, like gas sensors, because there are 15-20 gas sensors out there. So I didn't name them, but even if you use the gas sensor or some water detector or some other types of sensors are available, make sure the direction is correct. VCC will get VCC, ground will get ground. That's the only care you should take. Programming anyhow, that's not an issue because that won't damage the components. Similarly, touch sensor. You can see the first is ground, second is VCC, third is the signal. And this vibration sensor, you can see first is VCC, second is ground, third is the signal. Pressure sensor, first is VCC, second ground, third and fourth are the signals, right? So gas sensor, you can see gas sensor, first is VCC, second is ground, third is the signals, fourth is also signal. Sound sensor, first is VCC, second is ground, third is output. So whenever you pick up any sensor, first verify which pin is where, and that should match, because we are externally mounting. The components which are already there on the PCB, there is no worry, because I already explained the flat portion should be this side, right? Or the optocoupler, the name should be outside here. It should indicate like that, that not a problem. But here on these slots, either you can put it inside or you can put it outside. Both the options are there. But that may reverse the polarity, which may damage the components. So that's why you should verify the pins and on your circuit also. Like stepper motor. Stepper motor is a five pins, right? So there is a red is your common wire that goes to first pin. Then your coils, first coil, right? Second coil, third coil, fourth coil. Accordingly, you should organize while mounting. So where that will go on your PCB motor connector. So we have given a star here. That means a red wire of your stepper motor should come here. Then remaining 4 wires. If you are using a DC motor, then ignore the first wire. Second, third is for one motor, and uh, fourth, fifth is the second DC motor. Okay. Similarly, servo motor, you can see there is a color code, right? Brown, red, orange. So again, it should has a polarity. I have some videos on YouTube to begin with. Be familiar with the Arduino as a compiler. Again, I repeat, we are not talking about Arduino boards. Board is supposed to be designed, fabricated, tested by you. However, nothing wrong using the compiler, Arduino compiler. And then I explained before using this board, I explained just to use the ESP32 and do not even solder the board. By using ESP32, I have explained in these videos how to connect it to the Arduino, your computer, and installation, and then writing the programs. One should understand first what is compiler, what is embedded C, what are the commands in embedded C, what are the other traditional C language commands, syntax, like conditional statements, operators, and pointers, arrays, right, functions, data types, most importantly data types. So those are explained in these videos. I expect you first practice every session of these basic codes, and I'm also sharing end of the training program all these, not only the videos in the beginning I am sharing, but solutions also I am giving. So in case if you are unable to do it, use those programs, but practice it, and next time write it on your own, do it yourself. And my subsequent videos are all about every single program of every sensor, every motor, including IoT protocols, cloud, and some case studies. I will be sharing different videos for different sensors, peripherals, and the case studies. All right. And finally, about the ESP32 itself, which is a 15 pins on left side, 15 pins on the right side. In the entire session, I was telling you the pins, right? The name of the pins. You can see uh, GPIO 36, 39, 34. This is what I was referring 27, 26, 25, 33, right? We have connected M1, M2, M3 here 27, 14, 12, 13, like that. So I was referring these pins. We might have given a different names, but you should compare which pin is where. For example, pin number 1 is enable, 2 is GPIO 36, 3 is GPIO 39. So that means when I explained my circuit diagram, right, what names I had given. See, first is enable, but this is what I was telling. Second is what? Second is GPIO 36. So then third is GPIO 39. So you should match because Arduino recognizes only these names, right? What is called 36, 39, 34, like that, not the your given names. But these GPIO pins are also having multiple functions like ADC, analog to digital conversion. You can see all these green names, right? GPIO 36 onwards to GPIO 4. They also act as a analog to digital conversion. And also there is a digital to analog conversion. That is, you can say D25, D26 or DAC1, DAC2. So two DACs are inbuilt. That's the beauty of this controller. And then the other UART peripherals, serial communication, right? Number 28 and 27, that is GPIO 1, 3, are act as a TXT and RXT. But two serial ports are there. Second serial port is available on pin number 17 and pin number 16. And touch means capacitive sensors also there, touch 0, touch 2, touch 3, so that you can also interface some, right, capacitive sensors here. So and I2C protocol, right, another serial communication protocol. So SDA is on 26, SCL is 29. Whenever you want to interface I2C serial communication devices. Similarly, SPI communication, you can see MOSI, MISO, clock and CS0. So this color, right, is meant for SPI communication. So how many serial communications you have? UART0, UART1, I2C, SPI. So you have total 4 serial communications and GPIO pins ADC, DAC. Internally, it is also having inbuilt timers and some other features like flash, RAM, E-square PROM and so on. This entire CPU is working on 3.3 volts. So when you give USB power supply here, it will give you 5 volts, or you can also give 5 volts on this pin, 15 pins. If you do not want to operate through this USB, then give 5 volts here. Then it will generate 3.3 volts on its own. Or you give 3.3 volts, no problem. Either way. So this CPU, you are not supposed to operate more than 3.3 volts. On any of the pins, do not draw more than 10 milliamperes of current. Otherwise, physically it will damage. That is the reason I was keep on saying that except LED or some sensors, right, or maybe buzzer at the most, do not connect like motors, relays, actuators, because they draw more than 10 milliamperes of current. So one should know first of all the legends, the names, because when I explained the programming language and in my subsequent videos, I will be always referring these names, right, these GPIO numbers, because Arduino compiler recognizes these numbers, whatever is given here. So when I talk about the installation, maybe next video, I will tell you how to install Arduino as well as the libraries. Because when you use some of the libraries, right, for example, if you want to use, let's say Bluetooth, if you want to use stepper motor, if you want to use some Wi-Fi device, then you are supposed to install some driver ICs. So those are externally, I will tell you how to install those drivers. So installation of the Arduino compiler, first step. Installation of the ESP-32 as a board, second step. And installation of the libraries as and when you want is the third step. And most importantly, installation of the driver which will recognize by your operating system, device manager, device driver is the also uh, the important step. Or I would say before installation of the libraries and the device, the ESP32, first install the Arduino compiler. Second, install the driver which will recognize this USB chip, that is CP2102 chip, Silicon Labs chip. So that I already explained, but again I will explain when I explain about the software and hardware installation and initialization. All right, thank you.